Okay, let's just do that again. Good morning and welcome to the Saturday Tut for today on inheritance. I will be going through the last week's practical. If you guys have any questions, please feel free to send a message. I think there's only 2 people here today, so you're welcome to ask me any questions you have regarding any part of the practical, and I 100% will have to answer them because you're literally the only person here. So that's a good thing, right? I hope you're not missing a maths paper to do this. So if you do have maths, this recording will be on YouTube or will be on Blackboard again. So you can watch it again, and I'll try and go through this in as much detail as possible. I do hope that helps you out a little bit. Do you guys have any questions specific to this practical? Would you have anything that really bothered you or something? I know a lot of people misunderstood the practical itself. So I'm probably gonna read the practical question itself, and then just kind of see what we can get from that. And I'm hoping that's a good start. Does anybody have any questions before that though? Yes, no, maybe? Can I explain the question itself? Sure thing. Okay, let's go. Let's share this screen actually. All right, so let me know when you can see this. Put your hand up if you can see my screen. Can you see my screen? Okay, cool. Thank you. At least you can see my screen. That's great. Thanks, guys. All right, let's look at the practical itself actually. All right, so here it says that the last unusual bank has traditionally been following a very manual process of recording the bank accounts of their clients in journals and ledgers. With founder William Banks III stepping down, his successor Vusi Shabalala is opting to change the bank's fortunes by adopting an information systems approach to the managing the bank accounts of its clients. Wow, sorry about that. My reading is buffering today. Okay, so there's 3 kinds of accounts, right? So there's a check account, a fixed deposit account, and a credit card account. Check account is mainly a transactional account with you got deposit and withdraw, which are actually debit and credit, right? Withdrawals are permitted as long as the withdrawal amount does not put the account balance into the negative, right? So we can withdraw until it is 0. So until balance equals 0, we can withdraw however much, right? And there is no interest, which is a great thing. Well, it's not great for the users, but it's great for the programmer, right? So then we've got a fixed deposit account. These are accounts where clients are able to deposit amounts at any time and withdraw money, right? So both of them can credit and debit, provided the amount to be withdrawn does not exceed what is currently in the account's balance. So again, unless it is 0, right? You can withdraw almost everything as long as it is not higher than the actual balance. Fixed deposit accounts are able to earn interest at a specific rate. Okay, cool. Then we've got a credit card account, right? These are accounts where the clients are able to make changes to their card or charges to their card, where they debit the card, and then they receive refunds where they credit the card. So the 2 above had withdraw and deposit. This one's got a debit and a credit, right? And the debits and credits are called charges and refunds, right? I have no idea why it's called refunds. Or they can pay into their credit card account called credit, right? So remember, everything is based on how the journals work in the back end for the actual bank itself, right? So everything has to come down to either a credit or a debit so that they can put it into their ledgers nicely. That's why all of these credits and debits are in brackets here. So you know whether it's increasing the account value or it's decreasing the account value based on credit or debit. Okay, so charges to the account are permitted as long as the account balance does not fall below the credit limit amount. The credit limit amount might be less than 0, right? So that's an important thing that you need to remember there. And the credit accounts are able to earn interest. They receive 0.15% or incur negative balance. So they both have they both earn interest. If it's positive, it's 0.15%, or negative balances earn 15%. All right, cool. So that's what we read from that. All right. Then okay, so here they give you a nice little table of what each bank account has, right? So, and then they said that the bonus is, instead of multiplying by 30 days for each month, investigate how you would determine how many days they are to incur. They are exactly in the current month, right? So, I'm not going to be doing the bonus with you guys. Then we see the design is 5 marks because we're really not interested in like input and output here. We want to see your how you do inheritance, right? So UML is important. The relationship that you show is important. There's a nice big hint in the mark sheet here. It says there's an abstract class, right? That means you're supposed to have a abstract class. You're supposed to have an account class. You're supposed to have instantiation of account classes, right? And you're supposed to have instantiation of classes, right? Interaction with classes, credit and charges, credit and debit charges, etc., etc., etc. Then we've got correct execution, form, look and feel, programming style, and then the bonus, which I'm not going to do, right? So let's take a look at this, right? So it says we need to have an abstract class. Now, I'm not sure if you guys remember from your lecture, but inheritance is a relationship, right? So a check account is a type of account, so it is a account, right? So that's how you can check for that, right? So, and the reason you check for, the reason we say is it comes with one important fact. One really, really important fact. It means that if you're going to have an abstract class, in the abstract class, you have to put every single common function, every single common method that is in both accounts, right? So I think that's really, really important to remember. You need to have every single method that is common to both, every single piece of information that's common to both. So all of the variables, as well as all of the methods that are common to all of the other accounts that are going to be inheriting from the abstract class, must be in one place. Otherwise, you're not doing it properly. All right, that's just the end of the day. That's how it works. Okay. So one of the things that's in every single one of these is every single one of them must be allow us to check the balance, right? Every single account checks the balance. Like you'll see, it's there, and it's there, right? All of them have the same kind of constructor, right? All of them have a debit and a credit, right? All of them have a debit and a credit. Every single one of them has a debit and a credit. So that's going to be the main 4 things that we put into our in our abstract class, right? And then once we've got that, then we can add the other 2, like in account, in check account, we can have withdraw and thing. In fixed deposit account, we know that we've got new, we know we've got check balance, we know we've got debit, we know we've got credit. So we can add withdraw, we can add deposit, and we can add calculate interest in there, right? So that's a cool thing there that we can do. And then we've got new, we've got some kind of limits. This is something that we're going to have to add. We've got check balance, we've got debit, we've got credit, we've got charge. So charge is going to be something we add, and deposit is going to be something that we add, as well as calculate interest. All right, so does that kind of answer your question regarding like regarding essentially the practical question itself, or do I have to like try and explain that a little bit better? Or is there anything specific that you guys don't understand? I'm about to just open a drink. Yeah, a snack, a quick milkshake. Sorry, I'm a bit hungry. Do you have any questions? Not yet. All right, cool. Just have a quick sip. Okay, so let's try and actually code this out quickly. So we know we're gonna have 4 classes, right? There's gonna be some abstract class, and there's gonna be 3 different classes that inherit from it, right? Please make sure you do your inheritance arrow in the correct manner. In your UML, you're liable to lose up to half the marks if you don't do a correct relationship, right? So please try and make sure that you get the correct relationship to show on your UML. Please pay attention to your UML. It's more important than ever to do your UML, because otherwise you wouldn't see what stuff you're repeating and where it's going and what's the problem, right? So let's switch over to Visual Studio. Hopefully you can see what's cracking on my Visual Studio. Sorry about that. Let's add some stuff. Let's add some, we have to add a total of 4 classes. So we're gonna add one class called account.vb. Right, then we're gonna add another one called checked.vb. I think it's fixed deposit account, right? I think that was it. And this one was a credit account. That's what I'm gonna put it as. Okay. Can you give me 1 second? I just need to sort this out for my mom one. All right, I'm back. Sorry about that. Let's go ahead and add our option statements in, because we always add option statements. Remember to add your personal info here. right? And then we've got option um, option one infer. Right. I'm gonna copy and paste these through all classes to play. All right, I think that's all of them. Now we'll start off with the basic account, right? So this is intended to be our abstract class, right? But it needs to have some variables here. So we'll call this internal states. Now the important part is, unlike with composition, we don't want to make these. Well, we could essentially make these private, but it wouldn't be inherited, right? So if you make these private, it's not going to be inherited down to the classes that inherit from it. So there's another one called protected that you can use. I'm not sure if you guys were taught protected. If you were taught protected, please can you like raise your hand, and or you were taught protected, right? All right, cool. So we're gonna go protected, and we're gonna say balance, right? As double. Right. If you wanted to make this integer, if you can properly defend yourself, it could be an integer, right? So if you can justify why it makes this an integer, for example, you could say everything that happens in the bank account will be considered cents, right? And so you won't have it as rands, and so 12 rand and 5 cents is not going to be like 12.04. It's actually going to be 1,204 cents, and that's still fine. The problem is it means that you're probably trying to it'll put a big limit on the amount of money that you can actually put in here, because if you have 1,000,000 rand, that's going to be 1,000,000,000 cents. So if you have 1,000,000,000 rand, it's going to be much more cents, and as a result you could run out of space inside the integer to do it, right? So you'd probably have to use something called like an unsigned int or something like that, and you don't know what that is yet, so you don't want to do that. You don't want to do that. So we're going to keep it as double for now, and we're just going to say we're just going to keep it as double for now. And then now let's talk about the methods, right? So some common methods that we're going to have in here. We can have something like balance check, right? Let's call it check balance because that makes more sense, right? And it returns a double, and this is a function. And this just returns balance, right? So then we've got a credit and a debit feature that needs to, a function that needs to be here, right? Now, what I'm going to do here is I'm going to make these just subroutines, because you'll see now in a bit why this is important. Why it was an important decision to make this a subroutine with no return type instead of having some kind of check as to whether the credit or the debit was actually. Yes, please speak to me. You're welcome to like raise your hand. I mean, sure. Yeah. What's up?
Yes, like I wanted to ask about the account name. Isn't also the common attribute or
Yeah, you can definitely have an account number as a common attribute. That's a great option. So we can have a protected ACK number as string, right? That should work. Anything else? No? Alright. Okay, cool. So here we're gonna have the credits. Let's have credits and some credits, and we're gonna have an amount in here. And what it's gonna do is so if we remember, credit is going to be plus equals. So what we can say is we can say balance plus equals credit. So or amount. Right, and that works. Right, then we're gonna have debits. That's also a common thing here. You could also have made these grids. I think. Actually, yeah, I think let's make these protected. Let's make these protected. And I'll tell you why. No. And the box is used. Sorry about that. I need to sneeze there. And we're gonna have this doing a. All right. I think this is it for our thing. I'm just gonna copy and paste protected up here. But we can experiment with protected now. So all of these are protected except for check balance, which is public. Because the reason I'm making this public is because I can call it from outside the inherited classes as well. And you'll see what that means essentially in a bit. But we need to make this must inherit, right? So what we can do is we can just type must inherit here. Right? And that's it for our account class. Then the next class we're going to go to is going to be check account, right? So let's go to check account. Check account, and on check account here, what we're going to do is we're going to say inherits account, right? and that's going to give us a whole lot of stuff. It's going to bring us the balance, is going to give us credit, it's going to give us debit, and it's going to give us check balance. So what we need to do now is well, we don't have a constructor on the above one, so we're going to put a constructor down. We're going to have public sub new. It's going to give us ACK number. That was pretty smart. The account number there. Okay, so account number as integer, and we're gonna have balance. So initial balance as initial balance. As integer. Oh, as double. Let's make it double. Account number. We should make a string as actually. I like string here. Because we don't do anything with the account number, right? We never ever actually do anything with the account number, so why should it be an integer? We don't subtract or add them, right? So we can just make it a string. In this, we could have let's actually put a constructor in here. I think we can do that. Let's pop a constructor in here. See, if I would know where I was going with this practical, had I done a design. This is why it's important to do a design, right? Sorry about that. Now, what do we have as a public? New. So, new. Right, and it's going to take in ACK number as string, and init balance as double. What it's going to do is it's going to set up a balance equal init balance. It's going to set up num equal the new ACK number. All right, cool. Now we can show you guys how to do the whole call the base, right? So you can say my base dot new, and we can set it ACK number init balance, right? And that should work. Right, so that's how constructing the check account done. Now we're gonna need to do a withdraw and a deposit, right? So withdraw and deposit will rely on the credit and debit. Can anybody tell me why I've got it as a string here? Well, I think there's only one person. Can you tell me why it's a string? So the reason it's a string is because we need to check if this worked, right? You remember in the thing it said that we can only withdraw as long as the amount is not, as long as if we withdraw it, it will not put it into the negative, right? So that's why we're doing this. So we can check for errors. So we can check if the person tried to withdraw more than they are allowed to. without doing a pop-up box in the class, right? That's really important. So what you're going to do is you're going to say if balance minus amount is greater than or equal to 0, then, right? And then we're going to put an else here. Answer equals you try to withdraw more than your balance, right? Then we can say, otherwise we can say answer equals successful. And it's not successful. So I'm gonna say withdraw has worked. So that's the thing. Now, another thing that I should warn you about is if you do this up here, it actually minuses it. So what you want to do is you don't want to do that. You want to say check balance, right? Minus amount. And that 100% will work, right? So withdraw only if amount is less than balance, right? So and then withdraw has worked. So what we're going to do here is we're going to say right now balance minus amount minus equals. Oh, actually, instead of saying minus equals amount, we can do a debit. That way you never deal with what's the problem with this? Oh, did I declare it as a did I declare debit as a integer? Why would I do that? That's dumb. Okay, so there we go. That should fix that's problem there. Now we've got a withdraw and we've got everything working with the debits and ta-da, we've got some feedbacks that can go to the person from this function, right? So and then now I'm going to add deposit in here, right? So it's going to be public function deposits, and inside deposit we're going to say also amount as double, but here we're going to say as double. Now the reason we're making this as double is because I want to return the balance, right? So we're just going to say and we're going to say return that should work. Now, if you really wanted to be pedantic, you could make sure that you're not depositing a negative, right? But it's not really necessary. Obviously, this is going to be running on some kind of ATM or something like that, so that's a cool thing. So this is our check account done, right? Now we can look at the next account, which is probably going to be the credit card, right? So we're going to get the credit card account, and now this one has something special on it. It has the limit, right? So Let's do that quickly. What's wrong with you? Yeah, so it's gonna give us a red line until we do the new. So let's quickly do that quickly. But first we need to ensure that we put down some. Oh geez, everybody's left, so I guess it's just me now. Sorry about that. Let's finish this quickly. So we know that this has to be a private limit plus double, right? And then we're gonna have interest rate in here also. And then we're gonna have some constructor to get rid of that line because I hate that line. And this is just a basic constructor. What I'm also going to add in here is I'm going to add the limit and interest rate. Sorry about that. And in here we're going to say my base new. And in here we're going to give it Agnum and init balance. Then we're also going to say interest rate equals to interest. I'm going to say limits equals to limits. Right. So that's how we do the public sub new, where we have some new stuff in here, right? Then what we're gonna do is we're going to let's do some stuff here. What you can do is we need a get and setter for both the limit and the interest rate. Right, so we're gonna make it properties. The one thing that I don't want to do is I don't want to cause overshadowing. So we're gonna put a nice little thing there, and we're gonna say, right, this is important because sometimes VB doesn't care about case. If it's not case sensitive, having a capital here might cause a recursion, which is not what I want to do, right? Oh. Here we return limits as you have been doing all of our property things, and here we'll set limits. And that's done. Right, then this is for right, we've got one for interest rate also. And here, this is supposed to be value. So, just so we know, okay, it's supposed to be value. Here we go. This is for actually setting interest rate. It's getting and setting. Alright, cool. So now we've got the stuff that can change this once the account is created. Right, then the next thing we're going to need is a charge and a deposit, or a deposit, right? We can make deposit and refund one thing, because it's really not going to be a big deal, right? The reason being is because they both do the same thing. They both just call credit. You can make them different if you want to, but I'm not going to, because I'm going to save time, and I think that's a quick and easy way of doing things. So it's just going to be so these are going to be methods. Sorry about that. Refund, and it's going to take an amount. Right, and this is going to call amount from our base, and that should be fine. And actually, that's done. Now we're going to do charge, right? So, public. This one again is going to be a function. We can actually let's keep what we're doing and go function as double, and then we can give it a we can return balance. Right? Let's keep with what we've done on the first, or what we've done on the check account. In this function here, what we're going to do is we are going to charge. Right? And it's going to have an amount. Double. Okay. Should we do it as double like we did in the first one? Same bank, same principles, right? Right, so yeah, we're gonna have to have a quick check, right? So we're gonna say if amount is greater than balance, let's think about this, right? So if the limit is we've got a 10,000 Rand credit limit, right? That means it can be 0 plus limit, right? So what you can say is you can say balance plus limit. So if amount is greater than balance plus limit, then only is it incorrect, right? Because a limit can be below zero. We can have a credit limit that's above above what our balance is, right? That's just a cool little thing. If you do this differently, if you interpret it differently, it depends on how you justify it to your marker. Your marker should essentially give you marks based on whether your justification and thinking and solving the problem is correct. Because we want you to be able to solve problems. Your client will tell you whether you got it right or wrong or right when you're out in industry, right? So that's just a thing. If amount. Let's do it like this, right? So we're gonna say check balance plus the limit minus the amount, right? Is greater than equal to 0. But we want this to be done first, so let's just put that in brackets. Anyone else here? And here we're gonna return. So if it works, then we can say yes, it worked, and we're gonna just going to debit the amount quickly. So it's gonna debit. Right, and then here we're gonna say answer equal uh, charge successful. I hope that's how you spell successful. Else we're gonna say answer and say limits exceeded, right? So that's how I'll do it. Custom charge function. Charge, right? So this how you check this is based on your own interpretation, right? It depends how you worked it out, how you tried to do it, right? Because essentially you could have said you could have just added the limit to the balance and kind of went to that, but that's not a great way of doing things because you want to know I have positive value of like 43,000 in my account, and I can take off an extra 10 from there as an overdraft or whatever the case might be. That's my credit limit, and that's how we'll work with that, right? So if I'm interpreting this wrong, I am sorry. Please just ask the lecturer. But it's just basically one if statement that's going to be a little bit different there. All right, what else goes into this? We've got the deposit refund. The calculate interest function, right? We've got calculate interest. All right. Okay, so there's nobody else here, so I can't ask if anybody has any questions. So let's just get into that. The special thing about the credit card interest was that if it was positive, you multiply it by 0.15%. If it was negative, then you're going to be multiplying it by 15%, right? So that's pretty weird, right? So let's just try this out. So as I said, if the balance is negative, right? So if the balance is let's say less than 0, right? Then it's negative. So you can say balance basically negative, right? But else, if it's not less than 0, it must be 0 or greater, which means balance is positive. Now, there's a slight mathematical debate whether 0 is positive or negative. In this case, we're just going to assume that 0 is positive, right? And what we're going to do in here is we're going to say, well, if the balance is negative, we're going to say, we can calculate how much interest must be earned, right? So calculating interest is, it's some percentage of the balance that we're adding to the balance, right? So let's try and do that quickly. So we know it's going to be balance multiplied by something. So if it's negative, it is 0.15, right? Because that's 15%. Daily, which is 365. And then this is going to be times 30 days, because I'm not doing the bonus for you guys. Right? And then what we get is we get some value from this. And now what's important to remember is that this value is 100%. So this is a positive number. This is a positive number. This is a positive number. This is a positive number, right? So we're just going to credit it. Because all of this will give us positive numbers, and this is a double. Now, one thing to remember is let's just think about this again. All right, so we know that the balance is negative, right? So we're sitting on like -1 rand, and we calculate some interest rate, so that's going to be like 0.015, right? That we're trying to add there. And when we add it, is it going to add to what we have or what we owe? It should be to what we owe, right? So this should be a debit, right? That's just an important thing there. And I'm going to copy and paste this for the bottom. But instead, this is going to be 0.015. And here, this is going to be credit, because now it's stuff we owe. And now it's stuff we own, not owe, right? So this, if we have a positive balance, it should add on top of that. Right? If we have a negative balance, it should take away more money, right? So there we go. That's calculate interest essentially. And yeah, that's the whole of that. The credit account. And I think the only one that's left is fixed deposit account, right? Yeah, so fixed deposit account is going to have some stuff here. Let's talk about fixed deposit. I forgot what's in fixed deposit account. So in the fixed deposit account, we've got a new, we've got check balance, credit, debit. We have a withdrawal, and we've got a deposit, and we've got calculate interest, right? But the attributes are also going to be account number and interest. So this one had a limit here, right? This one here has interest. Oh, wait a second. If we use that's one thing that we missed out here, right? We didn't use our interest rates as a double. Why didn't we use the interest rate as a double? Weird one. We could have made interest. So, but this is for different interest rates. So this might change at some point. So this is not necessary. If you did this item marked you wrong, you need an interest rate here. You did not need an interest rate here, actually. Now that I think about it. So we could kill this whole thing off here. Yeah, so that's, but I'm not going to do that now because it's going to take too much time to remove. So you didn't need this interest rate. I was mixing up my accounts. I was mixing up my accounts. Let's just take a proper read here quickly. All right, I'm just going to close that. Fixed deposit account, right? It has an account number. It has a deposits. We've got a check balance. We've got credit withdrawal. We've got to calculate interest. Calculates the interest to be credited. And this is the balance times the interest rate divided by 365 over there, right? Oh wait, this one also has an interest rate. Huh, weird. Weird. Well, I'm not gonna go change that now. But ideally, we could have actually used the interest rate here. We could have actually used it. It's a bit weird giving a class to nobody, but I'll continue. I don't usually talk to myself while coding, so this is a bit weird. But essentially, what we can do is I think we can copy and paste the calculate interest function, right? And just swap out the 0.15 with an actual interest rate, which should be pretty cool. The same with the new. The only thing we'll take away is the limit, and that should be fine. Here it says that you don't need to put in the interest rate here, right? I don't think we'll take away marks if you did, but ideally try and follow your instructions to the T. So don't do what I did. Actually read your instructions, right? This is an instruction. Make sure you read the instruction. Make sure you deal with the instruction appropriately. All right, so let's get to a fixed deposit account. Let's get going with this one. All right, so what did we need here? We needed a inherit account, and let's do the public sub new. Wait, actually we needed some state variables, yeah. And the thing that we have here is interest rate, so we're gonna have and that's the constructor done. And then the next thing we're gonna have is a withdrawal, right? So we need something to the interest, so okay, cool. So then what we need is some kind of, we need some withdrawal and we need a withdrawal and a, what's it called again? Withdrawal and a deposit, right? You could have made this a three-step hierarchy where you had an account that has a withdrawal and so with a withdrawal and a deposit on it, right? And then the only one you didn't use it for is the credit account. That could have worked. That could be fine. But the reason I didn't do that is because I'm showing you a basic version of inheritance. If you did that and you justified yourself appropriately, you would have had no problem with that, right? So just putting it out there that you could have solved this in many ways, right? So that's just the thing. So we'll need withdraw and thing. I'm just gonna go back and steal withdraw and deposit from here. Particularly deposit. Deposit is pretty easy. So that's deposit. Right, and then we've got withdraw. Now let's just check on the rules for withdraw quickly, right? We've got a fixed interest account. We've got withdraw checks the balance and subtracts the amount from balance as long as balance will not be zero. Right, so I'm gonna just steal withdraw from my check account instead. And I'm gonna steal interest rate thing from here. But instead of having 0.15 here, I'm gonna have interest rates. And I don't think you can have a negative value. So actually it's going to be this one. And that's done actually. Yeah, so so we multiply it. Let's just make sure. Here we've got calculate, so it's balance times interest divided by 365 times 30 and credits taken. Done and dusted. So yeah, that was like literally like 10 minutes, like not even 10 minutes, and we did this. That was a good time. That was a good time. So just structure the way you code in a way that allows you to do stuff quickly. All right, and that's everything, I think, right? Yep, now we go to the form. So the actual application, right, that you had, it doesn't really talk about what you have to do. So what in terms of input and output, right? Design and implement a Visual Basic enables users to create one of each account, fixed deposit account and a credit account. And the user must be able to interact with the account as necessary, right? So the user should be able to create a check account, a credit account, and a deposit account, and then they should be able to switch between the accounts and deal with them appropriately, right? I don't think I need to go into how to do that. I don't think so. I don't think I have to do that. I'm probably, because it was left to you how you design the form and stuff like that, right? So that's gonna vary for person to person. There's no memo for that. So, and essentially what that means is there's no right way to do that. Well, there's many right ways to do that. There's lots of ways to do it. And there's no real wrong way to do it. As long as I can see the values for each of my accounts, I can add something to the credit account, I can add something to the debit account, and I can add something to the fixed deposit account, right? So what you could do is you could have 3 separate things here, and a grid at the bottom where you could have something here for fixed account, you could have something here for credit account, and you could have one here for check account, and at the bottom here you could have a grid with the balances for each one, and just continually, and just have a transaction 1, 2, 3, 4 at the top, or whatever the case might be, and pop some stuff in there. That could work out if you know how to do the transaction thing at the bottom or the interest rate thing. But essentially the form was left to you, so I think that's it for me. If you do have any specific queries on how to build up the form or how I would build up the form, then I guess you can just ask on the assistance server on the Axilab virtual server under the Informatics One thing, and somebody should be able to give you a better guidance on how to set up the GUI for this. Right? That's a cool thing to remember with that. Just to quickly go over this and tell you why I'm not gonna go further. From this, you obviously would have done design, you would have done the UML, you would have had an abstract class, you would have had the account class, you would have now instantiating them, right? That's 15, but that's the only marks you lose here, and then the form look and feel that I'm not doing, so 20 marks out of the entire 145 that I haven't done. So essentially that's really not a lot, right? So instantiation you guys have been doing with composition, so you shouldn't have too much of a problem with that. It's usually just calling the constructor. And yeah, so I think that's it for me for today. Have a great day. Since there's nobody else here, I hope you enjoy whatever you're doing on the day that you watch this, and good luck for your tests. It would have been, I think there is a test coming up, so good luck for that. Bye, guys.